Okay, hi everyone. My name is Rob Canzaneri, and I'd like to welcome everyone to the Data Architect virtual chapter. Quick check, Ron, you can still hear me okay, right?
Yep, all good.
Good, because last time we did it, we had a little bit of a problem with sound, and I just wanted to make sure we're on the same page. Um, so today we have Ryan Adams, was nice enough to join us for our meeting today, and he's going to talk about failover cluster and availability groups. So we are recording this session. And if you have questions, you can email me at pass, or you can use my email account up there, which is rob at sqltigers. I also have a little blog going on, www.sqltigers.com. Feel free to jump in and send me an email, or if you want to present, I'm always looking for people to come on and present information. You're welcome to join us. Today I have a helper, Kenny Neal. He's joining me to help me out, so he's going to ask when questions get asked from Ryan, he's going to work with us, and we're going to get your questions answered. So, if you're planning on going to pass, it's really cool discount code we have for our virtual chapter right here. You can save $150. Now, the really nice thing is if 10 people use this code, we're going to be able to give out another free pass conference. We've already given one out, which is great, and I think we need about 8 more to go or 7 more to go, and we can give another one out. So if you're going to pass anyway, use this code, please, and we'll be able to give out another free session to pass. So I'm going to say this name. I hope I say it right. Ibrahim won our conference last month. So congratulations. Um, I know he was excited and he's going to be there. And I look forward to meeting him. And I also look forward to meeting anyone else in our chapter. So if you see me, come back and come up to me and say hello. So there are a lot of chapters here. Um, they have a lot of topics. And if there's something you're interested in, please go to www.sequelpass.org and you can sign up for any of these virtual chapters. They always have great topics, great information. So another really neat thing to do, you can always volunteer. And if you want to get more information about volunteering, the website is volunteer@sequelpass.org. And there's always things to do, and I'm sure there's going to be an opportunity for you. So at this point, I'm going to switch over the presentation over to Ryan. Okay. Okay, Ryan.
All right, let's see. We'll show the screen here. Wait for that to pop up. All right, I think that looks good. You see that okay, Rob?
I see it and I can hear you, which is great. Thank you.
All right, fantastic. All right, folks, so this will be my second time, I believe, talking for the architecture chapter here. And last time we talked about just a high level about what AlwaysOn was, and we talked about how AlwaysOn consisted of failover cluster instances and availability groups. And that's just AlwaysOn is really just a marketing term that Microsoft used to cover both of those two fairly broad technologies. And so we talked about how we can design it, where do we want to place things, how do we want to configure those things. So today, the idea here is that we want to walk through and actually do that today. A little bit about myself. My name is Ryan Adams. I'm a SQL Server MVP. I do blog on ryanjadams.com, and you can follow me on Twitter. If you're on Twitter, I encourage you to go follow me there. Any new blog posts or anything like that, I'm fairly active on Twitter, and I do announce those blog posts out there. I'm also on LinkedIn as well if you want to connect to me there. As you can see, I speak at quite a few different places. The past summit coming up this year, I realize that I have the 2014 one on there because I did speak last year. I will be speaking again this year, so I'm excited about that. So if you get a chance to hunt me down and find me while you're there, I'd definitely like to meet you for sure. And I'm pretty involved in the PASS community. I actually help run the Performance Virtual Chapter. I help run the local chapter here in the Dallas, Texas area. I'm also a regional mentor in South Central, and I was recently elected to the PASS Board of Directors, which I'm extremely excited about starting that on January 1st. I work for Verizon. I worked for Verizon for the last 17 years. I've done desktop, server, just about everything you can imagine in between, including even doing Active Directory and designing and architecting that for Verizon worldwide. I fell in love with SQL Server. HANDR is kind of my passion. I love that kind of stuff. So that is what I mostly do now, is handle all of that. Now let's talk about the things we want to go over today. We'll talk about a failover cluster instance, and let me rephrase that. We're not going to talk about it. We're actually going to do it. So we're not going to sit here for the next hour and go over slide and slides and slides. In fact, there's only one more slide after this one. This whole thing is going to be demo because we're going to live deploy all of this, both in FCI and in AG, and we should be able to do that. Hopefully, if I'm good enough, we can get that done in an hour. So we've got a tall order of things to get done, but we can definitely do that. So we'll deploy both of those. If we have time, we'll take a look at how to utilize a read-only secondary. Kind of iffy on whether we'll have time for that one or not. So that's kind of bonus material if we can get to that. So let's talk about and describe just the architecture that we're trying to build out here. Now, this is not necessarily the kind of architecture that you would want to build in a production environment. This is just what we're doing for demo purposes, but the idea is to give you an overall idea of how we would design something like this. So the first thing we have here is we have 5 different servers. These are completely independent servers, and by that specifically we're talking about independent operating systems. And what I mean by that is that they could be virtual machines or they could be physical servers. Doesn't really matter whether they're VMs or physicals at all. There's really no difference here. But there are 5 completely different operating systems and completely different servers from a logical standpoint. And then what we do is we put them inside of a Windows failover cluster. Now, Windows Server failover cluster is required for a failover cluster instance of SQL Server. It is also required for an availability group. So no matter which one of these architectures you decide to deploy, you will have to have Windows Server sitting underneath that. Now, that is something I definitely don't have time to get into today. I've actually got another presentation. It's actually a 2-part presentation. I think it's a total of almost 3 hours to go over just the Windows piece, because of its importance in this architecture. And I can't stress that enough, that if you're going to deploy an availability group or a failover cluster instance, please take the time to learn the Windows side of things. When it comes to failovers in this architecture, SQL Server doesn't make the call. Windows makes the call. He decides whether you fail over or not. He gets some input from SQL Server to help guide him to make his decision a little bit better and put some context around it. But he's the guy that's the director. He's the guy that's going to make the call here, not SQL Server. So that tells you how important it is to make sure that you take the time, if you're going to deploy one of these architectures, to get the Windows side right. So what we've done here is we've got these 5 servers and we've put them in a failover cluster, and I've already done that for us today when we go to deploy this. And we'll work on the failover cluster instance first. Now, the failover cluster instance, one of the requirements of a failover cluster instance that we talked about last time is shared storage. So we do have to have a piece of shared storage, and we will have shared storage available to us in the environment that we build out today. And that is a single instance of SQL Server that can only be active on one node at any given time. Now, I show it here on server 1 and 2, and that's just to represent that it is going to be available to be failed over between server 1 and 2. We're not actually going to add nodes 3, 4, and 5 to the failover cluster instance, simply because it's extremely redundant. We just don't have the time to do that. Once you've done it on one, it's really, really easy to do on the others. You really only need to see it once. So that's what we're doing there. Then, after we're done with that, we're going to look at the availability group. And here what I've done is I've installed an instance of SQL Server 5 times. It is not a failover cluster. It's not a special install of SQL Server. It is a regular standalone instance of SQL Server that I have individually installed 5 times. Don't panic. We're not doing that. I've already done that. You don't have to sit here and watch me install SQL Server 5 times. Nobody wants to do that. But I've already done that. Completely independent instances. Then we have the availability group, and the availability group is nothing more than a logical construct that sits across those 5 instances of SQL Server. And what that allows me to do is take my databases and group them together. And we talked about all that stuff last time. And in this instance, we're going to have 3 different databases. Server 1 will be the primary, and then all the others will be secondaries. But we will have 3 databases inside of that. So this is the architecture we're going to build out today. Remember, there's technically 3 pieces of architecture that you're looking at here. You're looking at the Windows Server Failover cluster. Think of him as like if we're making a cake. He's the cake. And then we have a choice. We have a choice of how we want to ice the cake and what we want to put on top of that. We can either put an availability group on top of it, or we can put a failover cluster instance on top of it, or we could even put both on top of the same cluster, which is technically what we're going to do today. Now, I'm not saying the architecture here is necessarily what you would want to put in production to have both of these sitting across a cluster. I'm not saying it's not either. That's a business decision. But I want you to understand that technically speaking, these 3 things are independent. Windows failover cluster is required for both the AG and the FCI, no matter which one you decide to deploy, but you don't have to deploy both an FCI and AG. You can choose to deploy just one or the other. So, end of slides. Let's go take a look at how we can actually do this. And we'll start with the failover cluster instance. Now what I've got running here, and this is to show you that I've got 6 servers running. I've got a domain controller, and I've got 5 nodes, node 1, 2, 3, and 5. And we're going to spend most of our time running everything off of node 1. So let's go take a look at node 1. Let me go full screen here. Let's log in. And what we want to do here for the failover cluster instance, and I just want to show you that the OS is actually clustered. So this is failover cluster manager. This is what we see inside of Windows. You'll see that I have roles as highlighted over there on the left, and this would show me any roles that I have installed. And currently, you'll notice that I have nothing, right? This box over here is completely blank, so there's nothing installed at this time. If I click on the nodes, I can see, oh hey, I actually have all 5 nodes here, node 1, 2, 3, and 5, so they are indeed currently clustered together. They're all up and running. Everything looks green. So let's also take a look at the very last piece here is going to be our disks. So you'll see that I've actually got 3 different disks here. I've got one of my disks that I'm using for my quorum disk, and the idea is when we install the FCI, I have 2 drives. I have a J drive that I plan on putting my data files on, and a K drive that I plan on putting my log files on. So in order to start the install, and actually I have to come out of full screen long enough to stick the CD in virtually, we'll stick in my SQL Server 2014 CD here, running setup. Let me go back into full screen here. Still on node 1, just so I don't lose anybody, nothing's changed here. And we're just looking at node 1. I've just put in SQL Server 2014. Now, for those that are curious, on the Windows side, I am running Windows Server 2012 R2 in this environment, and we are doing all of this with SQL Server 2014. So we'll go under installation. Now, this is the very first node that we're going to install our failover cluster instance on. So the choice I want to make here is going to be the second one, and that is this new SQL Server failover cluster installation, the second choice that we see there. So we'll go ahead and click on that. And the good news is here, guys, if you do have questions, go ahead and type those into the box. We won't have as much time for wait time, built-in time during the availability group part, but here during the FCI, because you have to go through the GUI, we're kind of waiting for things to churn and all that kind of good stuff. We'll have plenty of time here. Oh wow, looks like I need to do a restart. Well, guess what? We're going to have to wait on that. Sorry about that, guys.
We do have a question.
Let's go ahead and do that while I'm restarting this guy then.
So they want to know, can they get a link for the Windows Server Failover Cluster configuration? Is there a link you can provide or recommend?
So I don't have that documented. You know, I actually don't have anything for that.
Okay.
Unless you're able to catch one of my presentations where I actually do talk about that. I don't think I have any for that one coming up in the near future, though.
Okay. Well, the next question we have is always on, if I'm reading that, is always on running only on Enterprise Edition? So I guess the question is always on a Enterprise Edition only feature? So
that is true. Availability groups specifically, so when we say always on, we want to talk about always on availability groups or FCIs. Now FCIs are available in every edition. both standard and enterprise. The kicker is if you're in standard edition, you can only have 2 nodes. That's the restriction. If you go to enterprise, you can have whatever the operating system maximum is. That maximum in Windows Server 2008 and 08 R2 was 16. In 2012, they raised it to 64. But availability groups specifically, those are only available in the Enterprise Edition in both SQL Server 2012 and 2014.
Okay. All right, here's a question. I've had to deal with this quite a bit. Is it recommended to have a separate shared disk for MSDTC?
Yes, you will need a separate shared disk for the MSDTC. Now, the interesting thing about the MSDTC is when you did a failover cluster installation, it used to be required. Even if you didn't need it, you still had to install it. They actually removed that requirement starting in SQL Server 2008. So when we go through this today, we won't have to do that. It's not a requirement anymore. Even though we're doing a failover cluster instance, we won't have to actually do an MSDTC if we don't need it. We won't do that today. All right, so it looks like it rebooted. So let's see if our rule check goes a little bit better this time. Thank God for SSDs, right, folks? Otherwise, we could have been sitting here forever waiting for a reboot. All right, so it's going to check its setup files. It's going to make sure that everything is good to go there. And for the most part, most of this stuff is fairly simple. It tends to go through and do most of the regular checks that you would even for a standalone up until we start getting into some of the selection options and choices that we have.
So here's another question. They're asking, is the closest option to always on with standard edition be database mirroring?
Yes, so that would be true. The idea is that availability groups would replace mirroring long term. That was the plan. So they are the newer version of that. Mirroring was actually deprecated. Mirroring got deprecated in SQL Server 2012. Our general Microsoft rule, and this isn't really a rule at all, this is just what we've historically seen them do with deprecated features, is they tend to keep it around for a while for like the next 2 major versions and then it disappears. So SQL Server 2012 would have been the first version, 2014 would have been the second, so we would expect it to be gone in 2016. It is still in 2012, of course, it's in 2014. If you can actually go download SQL Server 2016, the CTP, mirroring is still in the product. Now the product hasn't shipped, it's still CTP, so there's always a risk that they might yank it by the time it goes production. It goes, full GA. So, even though it's in the CTP doesn't mean 100% sure that it'll still be there in the final product, but from what we can see, it appears that it is still definitely there. But even if, and this is something to keep in mind because people, we had a question about the Enterprise and Standard Edition thing. So if you're thinking, well, if availability groups are the replacement for mirroring, how in the world am I supposed to handle that if it's Enterprise Only Edition and my company can't do that? Then what am I supposed to do in that situation? You're either going to be stuck with log shipping. 2, and I will say that you should go download the CTP just to see what may or may not be available in the CTP. And 3rd is that mirroring, if you go look at when the Microsoft support stuff ends, Microsoft mainstream support and extended support for SQL Server 2014, assuming that was the last version that it's available in, that doesn't even end until almost 9 years from now. Odds are you're probably going to upgrade and you're going to go through a migration and get new hardware within the next 9 years. So just because you see the fact that mirroring's been deprecated doesn't mean that you shouldn't deploy it. It is still a valid architecture. It is still something that you can absolutely use. It'll be supported for quite a while. So don't let the fact that it says deprecated scare you away from using a technology that is still good. Just pick the right tool for the right job, and that's the way to go on that one. So we come back and we see that it checks all of its rules. Now there's 2 things we've got a warning here on, and we can go ahead and go past the warnings. They're not a big deal here. And one of them actually does say, hey, look, the distributed transaction coordinator, let me go start my Zoom It tool here. The MSDTC happens to be one of them. And it's saying, hey, as far as the MSDTC goes, I don't see one. And normally I would tend to see that I would have the MSDTC on a failover cluster instance. Well, it's not required, which is why it's just a warning. So even though that's a warning there, we can actually ignore that and move on. We're not going to install an MSDTC. Now this second guy here, this one's saying, hey, I went and looked at the Microsoft Windows cluster validation report and I found some warnings in there. And I'm just reminding you that you have some warnings on the cluster side and the Windows side. It would probably be in your best interest to make sure that you go resolve those and make sure that everything's okay there. If you were to have any errors in your cluster validation report, the next box down here would be grayed off. You would not be able to continue, and it would not allow you to install a SQL failover cluster instance. But for us, we're good. We'll go ahead and click Next. Next one just wants the product key. No big deal there. Accept our license terms. No big deal there. We have two choices here. We do a regular feature installation or we'll do a power pivot. We're just going to do a regular feature installation. We're mostly just concerned about installing a failover cluster instance, which is just the engine itself. So we're going to go ahead and check that off. We're going to check this box off here at the top that says install the database engine. We don't need to worry about analysis services and reporting services. We're just going to do the engine here. On my VM, my instance root directory for the C drive here is perfectly fine. We'll go ahead and keep that. So far, nothing new over a standard installation. There's really nothing fancy here above and beyond what a regular install would do until this point. And so this point says, okay, now I need to ask you some questions about the fact that we're going to install this on a cluster. And what I want to know is, what do you want to call the name of the group? And so for our instance today, I'm actually just going to call this SQL+01, just picking a name here. I am going to use a named instance. I'm going to call this inst01. You can use a default instance. The only reason I'm using a named instance is because I actually already have a default instance installed on here. Because remember, from the architecture picture, I installed a regular standalone instance of SQL Server on all nodes across the board. So there's actually already a default install here in preparation for the availability groups we'll get to later. So we've got our network name up here, SQL+01. We're going to do it as a named instance. No problem there. Now that network name, remember, you're going to need an IP for that. You're going to need DNS for that. And this is what it's going to call the name. It's going to also create this in Active Directory. It'll create a computer object with that name as well. Now this is saying, hey, inside Cluster Manager, remember I showed you a minute ago inside Cluster Manager, we clicked on roles, it was completely empty. And they used to call it groups in Windows Server 2008. They renamed it roles, and it's saying, hey, what do you want to call the name of your role here that you're going to put all the SQL Server stuff in? And the red stuff down here just means that these are already being used. There's one called Available Storage, there's one called Cluster Group. You can't use those names. Well, I'm going to take the default. The default here is SQL Server, and then the instance name in parentheses. Sounds perfectly fine by me. We'll go ahead and keep the default. We're good to go there. Now it asks me about disks. This is definitely a little different. We wouldn't see this on a standard install. What it's doing is saying, oh, I found some shared disks here. Which ones do you want to add? Because maybe you don't want to add all of them for this particular instance. And as it turns out, we do. I want both cluster disk 2 and 3. So I'm going to go ahead and select both of those. I want to add them both. That red on cluster disk down there at the bottom was just saying, hey, you're already using this disk for your Quorum drive in Windows, so you're not able to do that. So now it's asking me, hey, what about an IP address? What IP do you want to use to go with the network name that we already chose? So I'm going to pick an IP address here. You have to check the box off before you can actually type in the box. I'm going to use 10.0.0.15. That's just my public IP address range. Go ahead and do that. And now it says, hey, what about the account names you want to run here? So I'm going to put in my domain and let's see, domain name and my account name with my password. I am a hockey fan. I live in Dallas, so Stars is my domain name. That's what you see there. SVC-SQL10 is the actual name of the account I'm going to use. Throw in my handy-dandy password. No need to change anything on the collation tab up there at the top. Don't forget to always check those sneaky tabs. It's always easy during a wizard to get caught up and click on the next button, but make sure we check those tabs. So now it says, hey, what kind of authentication mode do you want to use? So I'm just going to use Windows here. If you need mix, choose mix, add myself. And then on the data directories, I'm actually going to make a few different choices here on the data directories, because remember I told you that I wanted my data drive or my data files to be on the J drive and log files to be on K. So let's go ahead and make those changes. Data root and J is fine. My user database directory, I do want that to be on J, but the user log directory, that guy I want to change. So let's go ahead and change him to the K drive. And then I'm going to make one more change here. So these next two choices here are saying, hey, what about tempdb? We need to put the database somewhere, and we need to put the log somewhere. But take a look at, oh, I forgot to actually delete the existing letter there, sorry. Take a look at the letter I picked here. And hopefully some of you folks will remember this from last time. Now, one, this is a super bad practice. Don't ever use the C drive, the operating system drive, ever in production. But the point here is the type of drive that is. That's a local drive, not a shared disk. J and K were shared disks, but this one's not. So that seems a little weird that I would be able to put tempdb on there. And so that was a new feature that came out starting in SQL Server 2012 that we were allowed to put tempdb on a local drive on local storage. So if you're having tempdb contentions or you need to get better I/O performance out of your tempdb, we can put it on a faster local drive than if we were to put it on a shared drive out on a SAN. So we're going to go ahead and do that just to see how that works. So we'll go ahead and click Next. And we get a couple errors here. So one of them I'm going to fix. So the actual error, the warning's no big deal. We'll talk about that. But the error is saying, hey, I went out here to go create tempdb, and the tempdb already exists. That's my fault. I didn't clean up after myself from doing this once before. We just need to go delete it. My apologies on that. I should have pre-cleaned that up. We'll go ahead and toast those guys. We'll click Next so it'll redo the check again. And then we'll just get a couple of these warnings. And the warning box pops up. Here's what it says, if I can fit this all on the screen there. It says, hey, you specified this local directory on the C drive for tempdb. And if you want to avoid any failures in the future, what you need to do is go to every other node that you plan on installing this on, and you need to create that folder structure that we're showing, which is going to be this guy right here. This folder structure needs to exist on all your secondary nodes, and whatever account is running the SQL Server service needs to have permissions to create and delete files in that folder. Now, the interesting thing is, I'm going to go ahead and click Yes here and continue on. This is just a confirmation box. We'll go ahead and click Install while I talk about that choice a little bit more. Now, with that choice, the interesting thing about that guy is he says, well, you need to make sure about this on the secondary nodes, but he doesn't say anything about the primary node. So what he's going to do is he's actually going to go in and he will create that directory structure right here on the very first node. We're on node 1. He's going to create that for me. And he's going to make sure that the account has the permissions that it needs. Totally takes care of that for you. You don't need to pre-create it, don't need to worry about it on the first node. However, you do need to worry about it on subsequent nodes. For whatever reason, the install, when we do the add node on the secondaries, does not give you, or not that it doesn't give you, but it does not create that structure for you and doesn't grant the permissions that are needed. You have to do that yourself. But here's what's kind of bad about this and what I don't like about it. It doesn't warn you on the next node. When we walk through the wizard on the next node, it's not going to pop up and go, oh, hey, by the way, don't forget, you need to create this directory structure, because if you don't, you're going to have a problem. The warning that you just got 2 seconds ago during this wizard is the only warning that you will get. You will not get that warning again, ever. And you may remember that because we're building the cluster right now, we're adding the nodes in right now, so odds are we're probably going to remember right now. But if you need to add a node 2 months down the road, 6 months down the road, 2 years down the road, are you going to remember that you decided to put tempdb on local storage and that you need to recreate that drive letter and path? There's a chance that you won't remember that. So what happens if we don't do that? We forget to create that path and we don't give the permissions. what happens to SQL Server if it fails over to that node? Well, it's going to try and create tempdb in that path in that folder structure, but it can't. If it can't create tempdb, SQL Server doesn't start. So now all of a sudden you've got a failover that occurs, but it doesn't work. It fails to fail over. And that's a situation you don't want to be in, especially if you only have 2 nodes, then you're completely down. So be very, very cognizant of that to ensure that, write yourself on a sticky note as you're going through the install, just to make sure you don't forget that when you get to the other nodes, we need to make sure that we've created that directory structure. Otherwise, we're going to have some problems. Now the good news is it looks like it's actually getting really, really close to being done with the install here on the first node. Sometimes this takes a little bit longer, but we are on an SSD drive here, so we're trying to keep the speed going. But Rob, do you have a question or two why it's kind of doing its last little few things here?
Sure. Okay, so one of the question is using tempdb. I'm using tempdb on a highest RPM disk. Is this best practice?
So I wouldn't necessarily say that it's best practice. This is just another tool in your toolbox that you can use to solve a problem where you're having tempdb. Now this comes into problems with high tempdb usage and tempdb contention. Now there are some other things that you can do to relieve that. And this is not a replacement for those other things, like making sure that you have multiple tempdb files and all that kind of good stuff. If you're interested in that, you can go to SQLsoldier.com. A friend of mine, Robert Davis, wrote a fantastic white paper on troubleshooting tempdb contention. This is just another tool to help you combat it even more, but it is not a replacement for doing regular contention troubleshooting. But yeah, not necessarily a best practice per se, but definitely a handy tool to have in the toolbox to help you if you get into that problem. So good news, it succeeded, everything came back green. That's what we always want to see. Now, let me close the dialog boxes here. Let's go see what this looks like real quick from the cluster standpoint. If I open a failover cluster manager, this is our Windows cluster manager, let's take a look at what SQL Server has actually done. So I can expand my cluster here, and the cool part is if I click on roles, remember it was empty earlier. Oh, hey, look, I've actually got a role here now, and it has the name that we gave it. Remember we chose that default SQL Server and then instance name in parentheses? That's the name of my role. Now if I want to see what's inside of it, I need to click the role. This is the one thing I don't like about the new server manager. And it looks like it's empty. You're like, oh, I clicked on it, and it kind of gives me some preliminary information down here at the bottom about priority and who owns it and IP addresses. But you'll notice there's this little tab down here at the bottom called resources, and they decided that they would hide everything underneath that little tab. And so if we expand that, I'll drag that up, and I'm just going to expand everything so we can kind of look at it a little bit closer here. We can see that here's all my resources. Here's that J drive that we decided to put our data files on. Here's the K drive for the log file. Here's the name that we'll connect a SQL Server with, and there's the IP that belongs to that name. Here's the actual SQL Server service instance itself. We decided to do a box instead of an arrow, and then here's the actual agent itself, the agent service. So we can see that it has installed absolutely everything on here. Now, one thing I will show you is if I look at the SQL Server itself, we go to Properties, we'll go to Advanced Policies here. This is a possible owner list. This means these nodes are possible owners that can own this resource group. And so far, node 1 is the only one with a checkbox. And that's for good reason. We've only installed it on node 1, so he's the only possible owner. And there's a reason why I show you that here in a minute. We'll come back to that. So I'm going to come out of node 1 to make things run faster. I'm going to kick out my disk, and we're going to go over to node 2 because I said that we were going to install this across just the first 2 nodes for a failover cluster instance. On this guy, we'll go ahead and stick in our install CD on this guy, and we do have different choices here. Let's go back full screen so we can focus in on this. Open up the install dialog, and the choice here is going to be a little bit different, right? Remember that first choice was for a regular standard standalone instance of SQL Server. The second one was if we were going to install a failover cluster instance. And then the third one, The third one is what you want to do on every subsequent node, and it's this add node to a SQL Server failover cluster. So we'll click the add node option here, and this is what you would do on every other node. You only do the new SQL Server failover cluster install, that second choice, on the first node. All the subsequent nodes, we pick the add node and go through the add node wizard. And the great part about this wizard when we walk through this guy is the amount of information to ask us for is a lot less. Because what it does is it goes over and it realizes that, oh, you're adding a node, you were already inside the cluster. It goes and looks and finds what the other node is, and it finds node 1. It'll go look in the registry on node 1 and pull out most of the information automatically for us of what we installed on that first node, so we don't actually have to input everything ourselves all over again. We're just going through its standard install setup files just like last time. It's looking through all the rules to make sure we didn't break any rules. Pre-rebooted this time, so we shouldn't have to do any funny reboots. Now, the options that you see here, this is exactly what we saw last time. A little warning about the MSDTC. We're not installing that, no problem. It found some warnings in our cluster, not a problem. We don't need to worry about that here. So we can continue right on. Those 2 warnings are no big deal. Enter the product key like we did before, our license terms like we did before. And then this was the first place where we had to start inputting some more information on the first node. But on this one, it pops up and says, oh, well, there's already an instance out here. Now, we could have more than one. Now, we only have one, and insta1 is the name of the instance that we installed. If we had more than one instance here, then we could have chosen which one or which instance we wanted to add this node to. Now, well, insta1 is what we want to add it to. It tells me the name of this node is node 2. And it can already, down here in the bottom box, it shows me, oh, hey, here's node 1. He's already a member. So we're just adding node 2 to this clustered instance. Okay, no problem. Sounds great. Click Next. Now, the network configuration is the next piece over here you can see that it's going to run through. And so the network configuration looks at, IP addresses and those types of things. And you'll remember we used 10.0.0.15 as our public IP address. Now, you saw it kind of took a second to populate this, and it always does. But it's checked off automatically, and the IP address is already in. There's actually nothing here for us to do because it went and grabbed that out of the registry on the other box. All we need to do is click Next. There was really nothing else for us to do here. It's going to ask about service accounts, and it pulled that out of the registry too. Here's the database engine. Remember that stars SVC SQL 10. It just wants us to reaffirm the password here. So I'll go ahead and throw my password in. We'll do that for both the engine and the agent. And we'll click Next there. See, a little bit easier than it was before. Not a whole lot of stuff to fill in. Pulls it automatically. Look, we're already at the end of the wizard. This is just a confirmation page. Let's click the install button and let this guy start doing the install. And this install goes even faster than the last one because we're really just adding a node here. So it's very simple. And then what we'll do is we'll actually go back and look at this inside of SQL Server to see what it looks like. And we'll look inside the cluster manager as well to see what it changed. Now the cluster manager change itself, kind of anticlimactic, but we'll at least show where that happened. Got any other questions there for me, Rob?
Okay.
Or waiting for this thing to chug away?
Let's see. Data and log files. Wouldn't we need some sort of file structure on all the nodes? Or are we using shared storage?
So we are using shared storage here. So remember, we're installing the failover cluster instance. We have not gotten into availability groups yet. That story changes with availability groups. But for right now, to keep the separation in our mind, just think failover cluster instance, which means shared storage. That is a hard requirement of an FCI, and that's part of the architecture of an FCI is that shared storage requirement that it is there. So like the J drive that we used, the K drive that we used here, those were both shared storage drives, and they are shared among both Node 1 and Node 2.
Okay. I have a question for you.
Yeah.
I heard in the newer version of 2016, or you'll be able to possibly add a 2016 as a failed over, like a cluster, a failover cluster, and fail it over, and it'll come up and upgrade you to 2016. Have you heard that?
Yeah, so that is a Windows thing, not a
Okay.
SQL Server thing. And what Rob's talking about here is today, if I have a failover cluster install and I want to upgrade my cluster, what's my path to get there? Well, as it turns out, there is no way to upgrade a SQL Server cluster. You actually have to create a new cluster, completely separate and independent, and then move your stuff over to the new cluster. There is no upgrade path. And it's mostly a Windows restriction type thing. Starting in the new version of Windows, Windows Server 2016, that story changes. And for those of you familiar with Active Directory, you'll definitely understand exactly how this works, like AD prep and those kinds of things. But what this allows me to do is bring up a Windows Server 2016 node, add it to the cluster, meaning that I've already got Server 2012 nodes. I can add a 2016 node in, and then I can basically start upgrading my nodes one at a time. And it basically puts it in like a temporary holding pattern kind of a thing where not all of the 2016 features are enabled until you've converted them all, but it actually gives you an upgrade path. The one big kicker to that is you can only do that if the existing nodes are Windows Server 2012 R2 specifically. Have to be that version. So if you were on an 0808 R2 or a 2012 RTM, again, still talking Windows here, you're still going to have to do a separate cluster. The only upgrade availability is if you were on 2012 R2 specifically in Windows and then going to 2016. Huge feature, though, to not have to duplicate hardware in order to do an upgrade.
I think that's awesome.
So it looks like everything came back green. Gotta love green. That's excellent. So everything went according to perfect plan. Gotta love it when a plan comes together. So let me go ahead and kick the CD out of here. When we're done with the install, I'm going to go back to node 1. We're going to kind of just continue to work with node 1 here. So if I go in and I right-click, this is switched back in Failover Cluster Manager. We just want to see what changed. We added this node. Where do we see that change? Where did the difference happen? Because if you look here, absolutely nothing changed. Everything looks the same. Well, if I right-click SQL Server and we go to Properties and go back to that Advanced Policies tab, the difference here is that node 2 is now checked off. So now that we've installed it, that's basically the only thing that's done is it's now made itself available in order to be failed over to. That's really the only change that we see here. Obviously, we can open up SQL Server. Let's open up SQL Server and see what it looks like there. So we'll open up Management Studio. Again, we're running SQL Server 2014 here. So inside Management Studio, now node 1 is what's filled in here automatically, but this is a failover cluster instance. And although if node 1 is the currently active node, I don't know that because honestly I wasn't paying attention on the other screen. Maybe it is, maybe it's not. If I were to connect to node 1 directly and it was active, great. If I were to connect to node 2 and it's not active, then we don't have a good solution there. What I really want to do is connect to the name, the virtual SQL Server cluster name, which is SQL Clus 01. That way, I don't need to know what it's on. I don't want to know what it's on. It is a named instance, of course, so we'll put the fully qualified domain name in, SQLClus01, stars.com, throw our named instance name on there, and then we can log in. That way, it doesn't matter whether it's running on node 1 or node 2, we're automatically going to go to the right node right out of the gate. So we want to make sure that we're using that. And sure enough, here we are. Default, of course, it's empty. There's no databases here. It's a brand new install. There's really nothing to see. If we wanted to know what node it was on, we can go query this. Let's hope this works according to plan because I'm going to pull this out of my memory here. Let's do select server property. This is the part I may or may not get right. Computer name, I believe it is physical. Net BIOS. All right, everybody cross your fingers, execute. Haha, my memory was good today, and it tells me, yes, it's currently running on node 1. If I were to fail this over to node 2, then it would tell me that it's running on node 2. So that's how I can figure out what it's running on when I log into SQL Server. I want to know which node it's actually currently running on. Now, of course, from Failover Cluster Manager, I can come back here. If I go up here to the top, I can actually see that here's the owner node right here. I can see that it's running on node 1. And we can fail this over. Now watch what happens if I fail this guy over. And what I want is I'm going to right click here. I'm going to say move, select the node I want it to go to. I'm going to select node 2. Now the first funny thing you're going to notice is, hey, wait a minute. It says that I could also move it to node 3, 4, and 5. Well, we didn't install it on node 3, 4, or 5. Well, remember, Windows doesn't know what kind of instance of SQL Server that you have on here. It doesn't know that you only added it to that. It doesn't really know a whole lot about SQL Server at this point. So it doesn't technically know that 3, 4, and 5 are not options. If you were to try to fail over to that, obviously it wouldn't work. So we'll select Node 2 because we know that that's our other good partner, and we'll click OK. Now, after I click OK, what I want is for you to pay attention to the resources coming online and offline down at the very bottom, particularly the SQL Server stuff. So you see down here at the bottom, look, it's going. There's the agent went offline. Everything's coming back online now. The disks are online. It's working on the IP, the network name. It's working on that right now, online pending. Now watch SQL Server. It says online pending. It's trying to bring SQL Server online. But let's watch what it does here. Now obviously it won't do the agent until SQL Server itself started. So it's trying to start SQL Server. Now the interesting thing here is it kind of seems to be, I mean, a failover cluster instance is a high availability feature. This is something that within this architecture should fail over very, very quickly. This shouldn't take a long amount of time. But for considering I'm running on virtual machines with SSDs and there's absolutely nothing on here, there's no workload or anything, this should pretty much be done by now. I mean, this is taking a really long time. Why is it this thing's having trouble failing over to Node 2? Well, remember, we decided to put TempDB on local storage, and guess what we forgot to do? We forgot to create that folder structure and grant permissions. So it's actually failing to fail over right now. Now, eventually it's going to fail back to Node 1, but look how long you're down waiting for this to happen. I mean, if you had a production workload on here, this could even take longer than what we're going to see here. And we're not going to wait for this because it's going to take a while, which is crazy. So you are inferring some serious downtime. So even for it to fail back to Node 1, assuming that Node 1 didn't actually fail, because in here we did it manually, right? It didn't technically fail. There's a serious cost to this. So proof and point, make sure that you're creating that folder structure. So that's kind of it for failover cluster instances. So we've installed a failover cluster instance across 2 nodes in this Windows cluster here. So let's go take a look at availability groups. Now, normally I have 2 different ways that I can show you how availability groups. We can walk through the GUI or we can walk through the T-SQL. And I'm actually going to walk through, of course it's pretty upset that I can't close this because it's not running. It takes a while to reopen up. What I'm going to do is I'm going to open up, oh, there we go, yep. No, do not save, close. What I want to do, I'm going to go ahead and disconnect from here. Now remember, we're not using this failover cluster instance. Just completely forget what we did. Okay, we're going into availability groups now. So put this whole failover cluster instance thing completely out of your mind. And I'm going to connect to Node 1 because he's the first node. Because remember, I have a separate install, a default instance of SQL Server installed on Node 1. And that's where we're going to put our availability group. And at this point, we don't have an availability group. You can see down here, it's completely empty. There's nothing going on. And let me open up my T-SQL here. So create app1 availability group. I'm going to go up here to query, and I'm going to turn on SQL command mode. What SQL command mode does, also let me zoom in. Let's change this to 150% so we can see it a little bit better. When you see stuff highlighted in gray, that's SQL command mode. And what that's saying is go connect to Node 1 and run all of this code on Node 1. And then go connect to Node 2 and run this stuff as if I were connected directly to Node 2. So it allows me to run this other code on the other nodes, even though I'm not actually connected to them. I'm only connected to Node 1 right now. So what we want to do is look at how this install goes. Now, we're basically walking through the requirements, right? This is essentially a checklist of items that have to occur in order for us to instantiate an availability group. And this availability group will sit across all 5 nodes. So first thing we're going to do is we're going to connect to Node 1. And what we're doing is we're creating a bunch of logins. And I have service accounts. SVC SQL 2 is running the SQL Server service on Node 2. And SQL 3 is running Node 3 and Node 4 and Node 5, so on and so forth. But what we have to do is we have to connect to Node 1, and we need to create a login for the SQL Server service that's running the services on all the other nodes. So I need to grant a login for 2, 3, 4, and 5 here on node 1. Now, subsequently, that would mean that if I were to go to node 2, then I would need to create logins for 1, 3, 4, and then 5, right? And then node 3, I'd need to do a login for node 4 SQL 1, 2, 4, and 5. And on node 4, it would be 1, 2, 3, and 5, so on and so forth for all 5 nodes. So we'll go ahead and do that. That's just creating the logons. So we're just setting the stage here. Oh, and to show you, let me expand my databases over here. You'll see I do have these 3 databases. We are going to add all of them to the availability group, but you can see they're regular standard databases now. There's nothing going on there. So we've created the logins. So let's go in and let's create our endpoint. Now the endpoint, you'll remember from last time, is our communication channel. And all you really need to know here is, and this is why I show you the T-SQL, because you can totally do this through the GUI. The only thing about using the GUI is that there's certain things that the GUI hides from you that you can do in T-SQL. And specifically for us here in the architecture virtual chapters, there's one specific thing that I want to make sure that I point out as you're designing this architecture. Remember, we're sitting on a Windows cluster, and there's traffic involved here, right? So the Windows cluster, there's heartbeat traffic involved, and that's what allows the nodes to have the whole voting and quorum and make sure that's up. And obviously that's outside the scope of today's talk, but that's one piece of traffic that's going on. And then the other piece of traffic we have going on is, well, we have communication, right? We have our user traffic, the people that are querying the database and actually accessing our data or whatever applications. So that's another piece of traffic. And then now we're putting an availability group on top of this. So an availability group has to replicate traffic, right? All the changes, it has to replicate that over to all the other nodes. That's an awful lot of traffic that we're pushing over a single pipe. In this instance, we're using iSCSI to attach to storage. That's even yet another piece of network that we're using here. What we want to talk about when we design this architecture is how do we separate that traffic? That's a lot of stuff going over a single pipe. How do we separate that? And so what we can do here is, if we specifically look at creating this endpoint, it's this piece right here, the listener IP equals all. This is what the GUI will do by default. My other choice here is I can put an IP address in here as opposed to the keyword all, which means that all of the traffic for the availability group itself, I can dedicate that to a specific IP. I can put that IP on a different network card inside the server. That way I can separate the traffic. If you use the GUI, that choice and that option is not going to be available to you. If you don't need this choice, if you don't need this option, and you feel more comfortable with the GUI, by all means use it. But if you need to separate your traffic when you're designing this, then this is what you need to make sure that you're actually doing. All right, let me zoom back out. So we're going to go ahead and create our endpoint here. And by the way, folks, if you go to ryanjadams.com and you click on my presentations on my link, you can actually go grab this slide deck and all of the code. So you're more than welcome to steal what I got and use it as a template. I'm a sharing kind of person, so no problem there. Now, the other thing is when we create the endpoint, those accounts that we created logins for, well, they kind of need access to use that endpoint, right? Because they're the ones doing all the traffic replication. So that's what we're going to do now, is we're going to grant connect on the endpoint that we just created here on this code up at the top to each one of those accounts. Obviously, we start out on node 1, so we need to grant it access to the accounts of 2, 3, 4, and 5. We go to node 2, we're going to create the endpoint. All this syntax here is perfectly identical. I'm not going to walk through all of it because remember, when you open this up and you look at this, it seems intimidating. There's quite a few lines of code in here and you're like, oh wow, this is a lot of stuff to look at. But the honest truth is remember, we're doing this across 5 nodes, so we're actually just repeating this. There's really not that much going on here other than the fact that whatever we do, we have to do it 5 different times. We've got to do it on each server in our availability group. So it's not as daunting as what it may look like if you're more of a GUI and you're not a T-SQL person. So I ran that. You saw how fast that ran. It created endpoints on every one of them and granted access to those endpoints to the accounts on all 5 nodes in the availability group. So now the next piece here is, if I go over here to Object Explorer, and you can do this on any instance of SQL Server that you have running right now, if you go under Management, even if there's no availability groups turned on, if we go under Extended Events here and look at Sessions, you'll notice that there's an Always On Health session down here. Now this health session is built in by default on since SQL 2012 on up. It's here. Even if you're not using Always On, you're going to see this session here. But you'll notice it's got a red down arrow, so it's disabled. It's actually turned off. But because we are using Always On, we're using availability groups here, we want to make sure we turn this on. That way we can track all of the health and the things that are going on inside of the availability group. So we're going to connect to each node, and we're going to do two things. We're going to, one, turn it on, and we're going to set it to make sure that after we restart that it automatically starts. That's all this code's doing. Obviously we have to do that. Node 2, Node 3, Node 4, and Node 5, we've got to do that 5 times. Go ahead and run that. In fact, if I were to go over here and refresh, I should see that that guy is now running. Sure enough, he is. You'll notice that he's now green as opposed to red like we saw before. Last couple things we got to do here is, one of the prerequisites, I'm just going to highlight this, we're not going to walk through all of this. We have 3 databases. Now, in order to instantiate an availability group, we have to take the databases that we're going to add to the availability group, and we have to back up the database. And right now the databases that exist here on node 1, we would have to back up the database and restore it on all the other nodes. And we would have to back up the log file and restore it on all of the other 4 nodes. And of course we have 3 databases, so we have to do that for all 3 databases. That's all this code is doing, is it's backing up all 3 databases and all 3 log files to a centralized share, and then it's going to restore them on each of all the nodes. And when it does this, the main key here is on the restore. You're going to notice that I've used this specific clause called no recovery. You have to specify the no recovery on the restore, because we're putting it in a recoverable state, basically saying that, hey, I am not done restoring, there's more restores to come. And since that is kind of basically what an availability group or mirroring really do, because they're constantly restoring your log files of your database, we want to make sure that we leave that in a restoring state. So that ran, that was successful, that's great. So now all the prerequisites are done. We're actually ready to create the availability group here. And again, I don't have time to walk through the code, and you can steal this if you want, but we're going to create the availability group. We're calling it app1ag in this line here. We're going to tell it what databases we want to include, database 1, 2, and 3. And then we have to specify the endpoint. And you'll see that this is, the endpoint for the first node, this is the endpoint for the second node, so on and so forth. So we're going to connect to node 1, and that's where we create the availability group. But all that does is create the blank availability group. That kind of creates the overall structure, but then we have to add stuff into it. It's kind of like creating a group, and then we've got to add all the resources in. So the next thing we'll do is we'll create a listener, and the listener basically says, I don't want to connect to node 1 because if he fails over, then I have to repoint my app to whatever node he failed over to, and I don't know what node that's going to be. So what I'm going to do is I'm going to create this listener. I'm going to call it app1ag. That way all I have to do is connect to app1ag, kind of like we did with the FCI, and it'll automatically take me to whoever is active. So that ran, that's great. And then at the very end here, what we do is we have to go connect to each node, alter the availability group, and tell that node to join. Right? So remember, we created the structure of the availability group. We have to actually join the node to the availability group. So we'll do that on all 5 nodes. And then the very last piece is we have to go to each node, and now that we've added the node, we have to add the databases on that node, and there's 3 of them, right? Connect to node 2, add database 1, 2, and 3 into the availability group. So we'll do that on nodes 3, 4, and 5. That's the very last step that we have to do.
So the tables go away.
And then we're done. So now let's go back over here real quick because we're right up against our time constraint, right at the top of the hour. I'm going to refresh my databases here. Check that out. They say they're synchronized now. That's pretty cool. That's a good sign. Let's go refresh the availability group section under here and see what we see. So I'm going to expand that out before I zoom in so we can take a little bit closer look. And sure enough, there's our availability group. We decided to call it App1AG. Sure enough, there he is. Here's all of the nodes that we added. Nodes 1, 2, 3, 4, and 5. You can see that node 1 is the primary right now. That's where he's running, and then all the others are considered secondaries. Here's the list of databases that are involved in this, because remember, I could actually have more databases on here that I didn't add to this availability group or that I wanted to add to another availability group. So this shows us what's inside of this specific availability group, all three of those databases. And then here's the listener. So if we wanted to connect to this availability group, if we wanted to connect to this availability group, that's the name that we would use as App1AG. We wouldn't use node 1, 2, 3, 4, and 5. So let's do that. Let's disconnect, because I'm directly connected to node 1. Let's disconnect, reconnect to App1AG, stars.com, fully qualified domain name. Make sure that that works. It should. Now there's, actually it's taking a long time. It's going to fail. Hang on. There's a reason for that. This is homework for you guys. Multi-subnet failover equals true. If you want to do a little homework, go do a little research on multi-subnet failover equals true. Go look that option up. What I didn't tell you is that node 5 in here is actually in a completely different subnet. You can have a cluster that is a multi-subnet cluster. I didn't tell you guys that up front, but we are running on a multi-subnet cluster. So sure enough, here we are. Let me open up a new query window here, and we'll do that same select we did before. Select server property, computer name, physical net BIOS. Oh, mistype there. And it tells me that I am running on node 1. Obviously, if we failed it over, it would tell me what node we're on. Last thing to look at is, well, what does this look like inside of Windows? Well, sure enough, here's the name of the group, App1AG, right up there at the top. That's the name of the role. I can see that it's running. I can see that it's running on node 1 right now. I can also go down here and look at the resources. Now, unlike a failover cluster instance, where remember, we saw a lot of different resources and items in there, right? We saw disks, and we saw SQL Server, and we saw the agent, and we saw an IP, and all this kind of good stuff. But an availability group, by contrast, doesn't have any of that, because we're not using shared storage. We're putting all of this database is on a local drive on the node, and we're literally mirroring it or copying it. So as of right now, we actually have 5 full copies of all 3 databases, because there's an individual copy on each node in the availability group, and it's sitting on a local piece of storage. In fact, it's sitting on the C drive, obviously bad practice, but for demonstration purposes. So all we see here is the network name, and this guy represents the availability group itself. Now this looks weird because normally this is the network name. This is that listener that we created right here that we were able to connect to. I'm shooting for an arrow there. But what is odd here is you will notice there is 2 different IP addresses, and this is the fact that we are in a multi-subnet cluster. So node 5 is actually in a different subnet. It's obviously in the 172.16 subnet in that network, as opposed to all the other nodes are in the 10 network. Again, didn't show you that part of the architecture, but this is fairly complex, right? We've built a 5-node multi-subnet failover Windows cluster. We've put a failover cluster instance of SQL Server across 2 nodes, and then we created an availability group across all 5 nodes. Now, obviously, we didn't do the Windows piece. I already did that for you. But considering that we just did a failover cluster instance across 2 nodes, and we did an availability group across 5 nodes, and we did all of that in right at just a couple minutes over an hour, I'd say we did pretty good today. So we accomplished a lot today. We bit off a lot of stuff, right? I mean, we only hit the surface, but this is 2 pretty huge concepts and different types of architectures that we built out, and these cool features between an FCI and an AG that we managed to build out today. So Rob, I know we're at the top of the hour here. That's everything that I had to show today. I'll throw my slide deck up just to have my contact information and stuff on there. just for everybody to look at. I'm more than willing to sit down and answer questions. The one thing I forgot to put on my slide here is I do a little consulting on the side of my spare time on the weekends through Linchpin People. So if you ever need help designing this type of architecture, surely make sure you shoot me an email. I'd love to talk to you about that kind of stuff. But Rob, if you got any questions, I don't know how far you want to go over. I'm
Sure.
happy to answer stuff if you want.
Well, we got a little bit of time today, so this is great. One of the questions was they want to know the impact of turning on the extended events for the always on. Is there an impact for performance?
So there's not an impact for performance. It's very minimal. I mean, obviously I can't sit here and tell you that there's no impact. But a lot of the data out of that extended events is what populates this. And this is the one thing I didn't show you here. Let me go back into Node 1, go back into SQL Server. The other thing that we can do to view our availability group is if I right-click on it and do Show Dashboard, this is kind of the pretty GUI piece. It kind of gives me an overall, here's what's going on, right? Everything looks green here. Here's the status of everything. Those extended events is where a lot of this data is coming from. So you really have to have that running. There is not a big enough impact reason for you to not turn that on. You need to have that on. Otherwise, you have no visibility into what's really going on underneath the hood.
Okay. Here's a kind of a question that I'm a little confused on, but I'm going to try and get it out there. So basically, they put Windows clustering plus mirroring equals always on availability groups. So I think they're trying to say, is that right?
So yes and no, and that's a really common architecture to do, and I frequently do that myself, where I've got like a 2-node failover cluster, because that solved my high availability problem. From an architectural standpoint, I'm trying to pick an architecture that solves a business problem, and using my 2 big business problems that we're talking about here to solve is high availability and disaster recovery. And a failover cluster instance can take care of the high availability because it sits on shared storage and I can fail over really, really fast. So the downtime is very minimal. And so what I might do is a 2-node failover cluster, and then I could take that instance and I can mirror that over to a 3rd node that's a standalone. Sorry, I shouldn't even use the word node. He's a completely different server in another data center for disaster recovery. And so he's asking, well, hey, is doing availability groups essentially doing that? It seems like it would be architecturally, but from a feature standpoint, it's really not. There's a lot of things that we talked about last time that availability groups do that an FCI would not do. For one, if you were to do that with, and you can actually take an FCI and put it inside of an availability group, by the way, but you lose automatic failover when you do that. The kicker here is that instead of mixing 2 things to come up with a single solution, I have 1 feature that I'm using to have a single solution. But you have to think about the differences, right? An availability group means that I have more than 1 copy of my database that's going to be shared. It does things like automatic page recovery that a failover cluster instance doesn't do. There are some features inside of availability groups, especially coming in 2016 from a performance impact, especially if you're looking at high OLTP, that you will get much better performance out of in 2016 than you have in previous versions. But you're not really comparing apples to apples here. I know from an architectural standpoint it sounds like that, but a mirror, the problem with the mirror is that you can't do anything with it. If you're on Enterprise Edition, you could take a snapshot off that mirror, but you can't touch it. With an availability group, you can. All these secondary databases, like nodes 2, 3, 4, and 5 here in this particular instance, I can actually go read those. You can't do that with a mirror, which means that I could actually take some of my I/O, like for, let's say I need to do real-time reporting. Well, I could actually go take a SQL reporting service and actually point it to the secondary nodes in order to relieve that I/O. That way I can take the reporting I/O off of my primary server where all my user activity is and point it here. So there are definitely some differences in the feature set there for sure. So at a surface it looks like they're comparable, but they're really not. It's just you're not comparing apples to apples.
Okay. Do you have time for one more?
Yeah.
Okay, here we go. Let's see. This is interesting. They wanted to know whether it's a good idea to have a witness server for availability groups and whether a file share witness will do.
So the terminology there is a little odd. So they're
Yeah.
saying, do I need a witness server, right? So witness server is something that we use in mirroring. We don't actually use that in availability groups. And what we're really doing is we're referring to quorum here. What we're wanting to say is all these nodes are looking at each other, and they're constantly pinging each other, trying to figure out who's up and who's down to decide whether we need to fail over or not. And in an availability group, Windows is doing that. Remember, we have a Windows cluster sitting underneath this availability group, so it's handling all that in its quorum mechanism. But mirroring didn't have that. So in order to accomplish that in mirroring, that's what the witness server came in play. So the witness server itself really only applies to mirroring. Now the other word in there that we got a little confused with was a file share witness. So when we set up quorum, and again, this is totally outside the scope of the SQL Server side because it's totally on the Windows side here. But when you set up quorum, there's a few choices. And you can do node majority, node and disk majority, which is kind of what we did here because remember we had that queue drive that I showed you. And we can also do with a file share. The main difference there is if this were in production and for real, because this is a multi-subnet cluster and I had a cluster node that was in a different data center because he's on a different subnet, then I would have needed to use a file share because I'm not going to be able to use shared storage unless I'm using iSCSI across nodes that are in a single cluster but they're in two different physical locations. That's where I would want to use a file share witness as opposed to a disk witness.
Okay, great. Well, we're kind of out of time here. I want to thank you, Ryan, for coming to the website webinar today.
Yeah, absolutely. I enjoyed it. Yeah, and if you have other questions and stuff that are in the queue, email those over to me and I'll write a blog post on it.
Sure, I'm going to go ahead and forward you the questions, and we got, I would say, 99% of them, 98% of them answered today, and I'll make sure you get the questions that aren't answered. And I'll put a link to your blog on the past site so anyone can get to it that's watching today, and the session is going to be recorded on YouTube, and we'll put a link on the archive site along with my site. I'll do a blog and point to the all that information. So I want to thank everybody for spending an hour today, well, a little over an hour and 20 minutes or so with us on our webinar, and we're going to shut it down now. I hope everybody has a great afternoon. Thank you.
Thanks, Rob.